to go 0.25 into 3.5 is something we can figure out because we know it takes 4 0.25s to make a full 1. 0.25, 0.5, 0.75, 1. Takes 4 to make a full 1. So I need 3 fulls, which is going to be 12, and then 2 more to get up to 0.5, 0.25, 0.5. So that's a multiplier there of 14. So the same multiplication has to work in the denominator, 14. So when I do 1 times 14, the result is 14. So we now know the length of the kitchen is 14 feet. All right, now if you don't want to solve it that way, remember, you can do the cross products. All right, you would say 3.5 times 1 is 3.5. So this diagonal has to make the same thing, 3.5. So I'm going to say, what number would I multiply by 0.25 to get to 3.5? Well, if you do 3.5 divided by 0.25, no surprise, you'll get 14. All right, now I only found the length, but I still need to find the width. Now, even though I'm finding a different thing, the scale doesn't change. So that 0.25 inches being equivalent to a foot, I'm not going to erase that. I'm going to use that again. All right, it's only the ratio on the right side that's going to change here. All right, so on the blueprint, all right, these two things have a width of 5 inches. Well, remember, my blueprint numbers are in the numerator. So when I write my 5 inches in, I need to write it in the numerator. And the denominator, well, that's going to be my variable, x. So I'm saying, what number would I multiply by 0.25 to get to 5? Well, it takes 4 0.25s to make a whole 1. And there's 5 of them now, 5 groups of them, so that's going to be 20. So the bottom here, I'm going to do the same thing, multiply by 20. When I take 1 and multiply by 20, the result is 20. So the width must be 20. So my dimensions of my kitchen are 14 by 20. Now again, if you don't want to solve it that way, you have an option here. You could say, okay, 5 times 1 is 5. The other diagonal has to make the same thing, 5. So what number am I multiplying by 0.25 to get to 5? Well, to go from 0.25 to 5 here, you'd be multiplying by, or the magic number here would be 20. It's 20 times 0.25 is 5. So it still doesn't change our result. Let's go ahead and take a look at one more, number 11. Scale model of a house is 1 foot long, and the actual house is 50 foot long. In the model, the window is 1.5 inches high. How many feet high is the actual window? So the scale model is 1 foot long, and the actual house is 50 feet long. Now they're saying in the model, right, the window is 1 1/5 inches high. And they want to know how many feet high is the actual window. Well, are you seeing the problem? Notice here the unit for the model is inches. But the unit here in the model is feet. You can't do that. You can't mix your unit like that. It's okay if we have different units going this way in this type of problem. Right? But we can't have different units going this way when I write my second ratio. So you've got a decision to make. You can convert this into inches, or you can convert this into feet. It doesn't really matter what you do, but do notice that the question is asking me how many feet high is the actual window. So we might be better off to put this into feet. But again, that's really up to us. It doesn't matter. Because once I figure out the multiplier, it's going to work for both sides. So let's convert 1 foot instead, because that's just so easy. Because you are screaming at the computer right now, 12 inches, 12 inches, 12 inches. Of course 1 foot is 12 inches. So let's make that change. Instead of 1 foot, I'm going to erase that, and I'm going to make that say 12 inches. All right, so when I come over here and talk about the model now, all right, well, 1 1/5, probably want to change that to a decimal. 1 1/5, well, the 1/5, 1 divided by 5 is 0.2. and you stick the 1 in front, and you have 1.2. And even though this looked kind of nasty a minute ago, it actually worked out pretty good. The bottom we don't know, that's where we're going to put our x. Now the reason I'm saying it worked out pretty good is because we're going from 12 to 1.2. Well, to go from 12 to 1.2, since the numbers are the same and the decimals just slid in, you know that involves 10. To go from 12 to 1.2, we'd be dividing by 10. So the exact same thing has to work in the bottom here, dividing by 10. So when I take 50 and divide it by 10, I get 5. So the window must be 5 feet tall. Again, unit consistency. You can have the same units across the top and the same units across the bottom, but you can have different units going this way in this type of problem. That's not a unit, not an issue. Again, model numbers all across the top, actual numbers all across the bottom.